Tonight, electric cars. Are they the next revolution in transportation?
These are very expensive vehicles to build. There's no clear evidence that consumers will adopt them on a large scale.
And Tesla, the electric car company that was first out of the gate. We'll talk to one of the developers.
We are certainly first. We have a very strong lead. Companies like Tesla are starting from the inside out.
Plus, how soon before we're all plugging in and powering up?
I would say that by 2020, maybe 30% of the cars on the road will be battery, electric, or plug-in hybrid.
We'll bring you the news tonight on Dan Rather Reports. Good evening. Dan Rather reporting tonight from New York. Our program this evening is about a very quiet revolution in the automobile industry. Electric cars that are whisper quiet and headed for a dealer near you. You may not have seen one in your own town yet, but just wait. Big auto companies and small startups are racing to get electric cars on the street. The technology is here, now, and many auto experts believe so too will be the demand. The next Detroit may well be in the Silicon Valley, where many of America's next generation of cars are being developed. The hybrids were just the beginning. Now some companies are tossing out the gasoline engine completely for good. For our program tonight, we have conversations with several people with intimate knowledge of the next generation automobiles. We begin where else? In California, the trend-setting capital of the world, home to Silicon Valley, the brains behind many of the new cars, and where for decades, automobiles have been about so much more than just getting from point A to point B. It's also the state with the most cars, and Los Angeles still has some of the worst air pollution. So into that environment comes the Phoenix, the Tesla Roadster, the Coda, the Leaf from Japan, the BYD from China, the Mini E from BMW, the futuristic Aptera. Do a quick Google search and you'll see how many electric cars are on the way. Electric cars that will forever snub gas stations. All they need is a wall socket and, like their owners, a little time to recharge. We began by speaking with someone who knows a lot about cars and California drivers. Dan Neal is the Pulitzer Prize-winning automobile writer for the Los Angeles Times.
Really, the transformation in the American rolling stock will be breathtaking, I predict. We're going to see millions of electric vehicles on the road very, very soon. They're coming fast. When they get here, they'll be expensive, and the real challenge will not be the technology on the four wheels, but the way we connect them to the larger electrical infrastructure. People say, well, we can charge them at home. The experience in California early on has been it's been difficult to build and connect chargers to people's homes. There's an issue of standardization. Different municipalities have different codes that have to be inspected. You know, it's a very bourgeois thing. You know, you've got to have a home in the suburbs to have an electric car. Where do apartment dwellers plug in their cars?
But perhaps more importantly, where do they get the money to buy them?
The problem is that these are very expensive vehicles to build, and there's no clear evidence that consumers will adopt them on a large scale. But nonetheless, manufacturers are building them. What you're seeing now in the electric vehicle market is just the first few thousand of these cars that are being built to satisfy the zero-emission vehicle mandate. So the government has been very active on this front. The Obama administration has passed a very demanding fuel economy standard, 35 miles per gallon by 2016 and on up from there. Those standards really cannot be met by current technology. And so the pump has been primed for electric and plug-in hybrid vehicles. That's one thing. The other thing is that the Obama administration has put billions into advanced battery research and has given billions to manufacturers to defray the cost of the initial investment in battery factories, in electric cars. Electric vehicles work great in Southern California because batteries are like people. They like it warm and not too warm, not too cold. Battery-powered cars are going to have a much lower performance envelope in Michigan or in Maine or in New York City because batteries simply don't work as well in the cold. This is a blind spot when it comes to the electric vehicle enthusiasts in California to say, well, why doesn't everybody have a Prius or a Ford Escape hybrid or indeed a full electric vehicle? Well, because a full electric vehicle probably won't work as well in Ontario. Not probably, definitely.
Batteries are the keys to winning this race. New technologies are being developed to squeeze every mile out of ever more complex battery systems.
These are the Wild West days of battery technology. There are all kinds of chemistries out there that conform to different kinds of performance parameters. There's lithium phosphate, lithium iron, lithium cobalt. There's sodium batteries. So the battery technology is all over the map right now. The winners will be several. There'll be the cost winner, there'll be the packaging and performance winners, there'll be the company that can sort of come up with the best compromise.
First out of the gate was an all-electric roadster developed in Silicon Valley called the Tesla.
You have to give credit to Tesla. Tesla was firstest with the mostest. You know, they took this sports car based on the Lotus Elise. They developed their own proprietary battery pack, a very big battery pack, but reasonably cheap, and so they built this sports car. You know, it's $100,000 and some odd, so it's not a mass market vehicle. In any event, they really were the first company to put a lithium-ion battery pack on board and make it work.
We'll have much more on the Tesla later in the program. And the big car companies are now coming on fast. Nissan of Japan recently announced production on an all-electric car with an environmentally friendly name, the Leaf.
Nissan has decided to make a strategic move in the direction of pure EVs. The company CEO Carlos Ghosn has said there's a million car market out there that's not being served. Nissan can build these cars. They've got a good technology and good batteries to do it. The Leaf is a real car, 100-mile range, 90 miles per hour top speed, 5-seat, and Nissan promises that it will not be that much more expensive than an ordinary car. Nobody really knows how this is all going to work out. We don't know if Nissan's choice is a good one or not. It seems like a good idea sitting here in Southern California, but the world and the market will have to have the final say.
Meanwhile, Toyota, the world's largest car maker, has decided to wait, recently saying all-electric technology is just not there yet. And they also have a huge seller in the hybrid Prius that runs on gas and electricity.
With regard to Toyota's decision to stay with hybrid and even plug-in hybrid technology as opposed to pure EVs, you have to respect Toyota's decision there. These are people who really know what they're talking about, and they were in the market with the first real game-changing hybrid. And so their decision not to pursue pure EVs at this time, I think, has to be taken seriously. There are a couple of caveats. Toyota has the patents on a particular kind of hybrid technology. They call it hybrid synergy drive. Naturally, they'd want to pursue and develop that. They're a very methodical company. They're more likely to want to develop that technology incrementally year after year than throw the long ball like Nissan has done and to develop a battery electric vehicle.
And into the race comes General Motors with another kind of hybrid technology. The GM car will be called the Volt and will go on sale in 2011. It's designed to compete with Toyota's hybrid Prius.
There are actually two kinds of hybrids, a parallel hybrid and a series hybrid. The Prius is a parallel hybrid, and it works like this. There's a gasoline engine and there's an electric motor. They work together to drive the wheels. They're working in tandem, parallel. The Chevy Volt works a little bit differently. What it has on board is essentially a small gas generator. That generator powers the battery, which, oh, by the way, can also be plugged in overnight and charged up. And that battery runs the electric motor. The advantage of this series architecture is that you can take a Chevy Volt and plug it in, and you can go as far as 40 miles before the gas engine ever kicks in. So if your driving typically involves no more than 20 miles per day, and a lot of people don't ever drive more than 40 miles a day, you'll actually never use any gas. You'll just keep recharging the battery at night and driving the car during the day. Now, if you go farther than that, the gas engine will kick on and will charge the battery as you drive the car. So the Volt's real great virtue is that it has unlimited range, because even if the battery is depleted, you can use the gas engine and put more gas in it. So you could take the Volt to Las Vegas without any kind of range anxiety. Americans are afraid of electric cars because they don't want to run out of juice. Perfectly sensible. I live in Los Angeles. If I wanted to go to Big Bear, a ski resort, in an electric car, I probably couldn't make it. The other problem is the psychological barrier of cost of ownership. Electric cars are much, much cheaper to operate than a gas-powered car. So when you buy a more expensive electric vehicle up front, you'll get that money on the back end, but we still have to communicate that advantage to buyers, and it's a bit of a tough sell. Americans are very short-term, temporizing kind of buyers. They don't necessarily want to pay for everything up front. So there's a real cultural dimension involved.
But the batteries, while much less expensive to operate than a gasoline-powered car, also need time to charge. So what about changing batteries or battery exchange stations?
Well, a couple of companies have proposed that in order to solve the range problem, you could swap the batteries out, just like camera batteries. There are a couple of problems with that. One, the battery is by far the most expensive component of the electric vehicle. So building or creating a backlog of these very, very expensive components to be swapped in and out of cars as they pull up to stations, it doesn't seem very economical. That's one problem. The other problem is one of some physics. Batteries are very heavy. They're also a little touchy, so you want to put those batteries in the center of the automobile, the longitudinal center, the polar center of the vehicle. So to improve handling and also in terms of safety, you don't want to break the battery if somebody runs into you.
But auto engineers maintain all these problems can be overcome. And Dan Neal says California, the state with the most hybrid cars, will also lead the way on electric cars next.
California is often the object of scorn. We're greenies, we're tree huggers, we drive our Priuses, and we somehow have this, we're smug about being environmental. But California and Californians have really led this mindset. And 20 years from now, when the world has adopted electrical mobility on a grand scale, it can be said that that started in California, USA. And that's something that we can be proud of.
Dan Neal of the Los Angeles Times. Up next, your correspondent takes the wheel for an electric ride. You'll want to see it, so stay with us. Missed an edition of Dan Rather Reports? Or just want to see one again? We're now available on iTunes, so check us out. This summer, a new business opened in an area of New York City that normally attracts trendy art galleries. But what went on display here is what the designers hope will be the future of transportation. This is the Tesla Gallery, or as we used to call them, a showroom. And this is the Tesla Roadster, the only car Tesla currently makes. It's American designed and built. It runs solely on electricity. Diarmuid O'Connell is the Vice President of Business Development for Tesla, a startup electric car company in Silicon Valley. He was on hand for the grand opening of the New York showroom this summer and was kind enough to let us kick the tires on the Roadster.
So what do we have here? So this is the most recent version of the Tesla Roadster. It's actually the sport version. It's a version that we developed this year that further optimizes the power of the car. Where the normal Tesla Roadster does 0 to 60 in 3.9 seconds, the sport version does 0 to 60 in 3.7 seconds. And you would think that those 0.2 aren't terribly relevant, but I can tell you that the driving experience is remarkably differentiated.
Well, walk me along here.
Sure.
The engine is, the battery is back here.
Yes, well, the whole powertrain is actually in the Roadster, is in the rear of the car. Let me just pop the hood here. I mentioned three main physical components, the first and most important of which is the battery. This is the battery here. It runs about 8 inches in, 1.5 feet down, articulated over the wheel well. It's literally a black box. It weighs about 1,000 pounds.
So this is the battery.
That's the battery.
Right.
This is the power electronics, and this is the inverter. We basically take AC power from the line, store it as DC in the battery, deploy it as AC to the motor. So this is the inverter. Below this, and you can't see it, is the motor. The motor looks very much like any electric motor, even from like a little slot car. It's about the size of a watermelon and generates about 250 horsepower. There's also a small single-speed gearbox.
And this is your recharger.
And that's the 110 charger.
So you just
plug it right
plug this in?
Yeah, here, I'll show you. On this side of the car, as I said, gas cap, which really reveals the electric charge spot. Turn it in like that, slot it in like that, plug this into the wall, and you're on your way.
Right.
So, very simple system. And it's a very simple car to drive in that there's no clutch, there's no shifting, the power is instantly accessible, and it's right there for you.
Now, here, is this for the aerodynamics of the car or a cooling system?
Both. In fact, I can pop the hood, if you will. I like to differentiate between what's under the trunk and what's under the hood as sort of new tech, old tech.
Right.
There's nothing really, I mean, this is all optimized architecture, but we haven't invented anything new here. The cooling system is a typical cooling system. For the purpose of this car, it provides the coolant both for the battery pack as well as for the cabin temperature.
Well, what do you say we take it for a spin?
Yeah, let's do that. Let's do that.
You game for that?
I'm going to offer you the keys. Would you like to take it for a ride?
Well, give me a quick instruction on the cockpit and I'll give it a whirl.
All right, hop in.
You know, one of the things that surprises me is there's already more than 500 of these been manufactured. I was under the impression, in my ignorance, that maybe there were a dozen or two.
Well, it's actually one of the reasons why we're so excited about coming to New York. You know, we've had a presence on the West Coast, and we haven't been as visible out here. So we're anxious to get out here and build awareness.
So that's one reason you have it down here in Chelsea and New York City to
build some
raise the
marketing
profile.
awareness, say the cars are available, they're available now, and come and try them
got
out.
it.
Good. Right, now,
All right, so take me through this, if you
all
will.
right, very simple. You've got an accelerator pedal. We don't call that a gas pedal. It's an accelerator, and you got a brake. And then there's a foot pad on the left for your left foot, which will have nothing to do.
All right, now I'm going to make sure this is the gas pedal.
That's probably the brake. I mean, the
That's
gas
probably the brake.
accelerator is
Oh,
on
it is
the
over
right.
here.
Yep, there you go.
And the gas is here.
Yeah, and if you want to adjust the seat, you can. There's a little bar underneath if you want to move forward or back. It won't go much further back, I should say, but.
Yeah, I think I'm all the way back.
Okay,
That's
good.
where I need to be.
All right, then put the key in the ignition, right
There it is.
there. Yeah. Okay, turn it all the way over.
All right, let me make sure here. We got our turn indicators here.
Everything, yeah, exactly. Turn indicators where they should be.
Windshield
wipers there. Normal. This is the AC system, ventilation, defroster, stereo system, as I mentioned, navigation, satellite technology. This is where we should find the vehicle in park when we turn it on, and we'll hit the button for drive. There's a video screen here which will give all our vehicle diagnostics. You indicated how do you see where the battery life is, how do you manage where, that's all provided here.
Right. Well, let's crank it up.
Okay, turn it all the
I
way
have
over.
an emergency brake on,
Yep,
which I
you
want.
need that on. Turn it all the way over and release.
Well, it's not running.
You're good to go.
I
Drop
don't
the
hear
button.
anything.
Yeah, you won't hear anything. In the best case scenario, all you hear is the ambient. There we go.
Are you up for this?
Absolutely, absolutely.
Try not to run over the cameraman. No, not to worry. Well, it takes a little getting used to because it's instant response.
Right.
This car does have some serious power for the road, and no doubt would fly down Manhattan streets if you let it. But maybe that's not the best idea in New York City traffic. The Roadster is fun to drive, but you'd better be on good terms with your passenger because it is a snug fit.
But not a bad ride.
Not yet in the showroom, but coming in 2011 is the S Tesla model. Currently in production in Northern California, it's an electric car that will be funded partly by tax dollars. The S, according to the company, will seat 7, retail for about $50,000, and have a range of 300 miles. And the development of the S model allowed Tesla to win a $400 million plus package from the federal government.
Well, you recently got a government loan. This is a federal loan that the company got. Tell me about that. What is the loan?
Well, the loan that we received is part of a program called the Advanced Technology Vehicle Manufacturing Program. And we were very fortunate to be among the first 3 recipients of the loan program. The intent of the program was to both help manufacturers develop efficient vehicles, but also to stimulate American manufacturing. So we're going to use the funds to create 2 manufacturing programs. The first of which will be a powertrain manufacturing facility. This is a facility that we'll build in Northern California. We'll borrow about $100 million to build the facility. And in this facility, we will be building the batteries, motors, and other components that we will supply to other automotive manufacturers who are buying our powertrain, our battery electric powertrain, to implement in their vehicles. The other part of the loan will help us to manufacture our second vehicle. It's referred to as the Model S. It is a 7-passenger vehicle.
Whereas the sports car model, the first model,
the sports car
2-person.
Is a 2-person.
I want to talk a lot. There's so much ground I want to cover with this because there's so much I don't know, and I think the public doesn't know about electric cars. But on the loan is for how much?
The total loan package is $465 million.
That's taxpayer money.
That's the total loan draw available, yes.
Have you seen any of the money yet?
No, because the money is drawn on an as-needed basis. So we incur costs, we pay our vendors, and then we present the documentation to the Department of Energy / Department of Treasury, and they refund our loan.
Well, forgive my ignorance, but who has financed it up so far? Is this a public company?
This is entirely a private company. Up to this point, there have been no public monies expended in the effort to develop Tesla Motors, the Tesla Roadster, and in fact, there will be no public monies expended to further the Tesla Roadster in any way, shape, or form. Not for further development of the Roadster, not for marketing of the Roadster, not for this facility or anything associated with it. So this is all about the future.
The Roadster being the sports car, the first one.
Correct, the sports car.
All right, whose money is in it so far?
Oh, so I'm sorry. So private investors. I mean, this is the Silicon Valley startup business model.
Well, you mentioned before that your plan is to bring to market in the future cars that are lower price. But how soon will the average consumer, say man, wife, 2 children, is thinking about buying a car in the $35,000 to $40,000 price range, somewhere in there, how soon before you'll have that to market?
We will have that to market, I would say probably in the 2013 timeframe. We're already doing some planning, but we are first and foremost focused on getting the Model S to market in 2011. I think it's safe to assume sometime in 2013, 2014 timeframe. So the sedan, the Model S that I was talking about, is going to come to market about $50,000. It's going to prove that we can get to low price points and high volumes very quickly with this technology. I very often say to folks, you know, the way you should look at the Tesla Roadster is this is the $3,000 cell phone of 1985. You probably remember that technology. It was,
Had one, as a matter of fact.
Exactly. It was a little bit bulkier and less attractive than a Tesla Roadster.
Well, help me here. That I've thought about electric cars, as I think most Americans have at least a little bit over the years. I may be able to charge it at home, but if I'm driving to grandmother's and it's more than 244 miles, I'll be in trouble because not many places have a plug-in, if you will. How do you get past that?
Very easily. Not only can you plug into a 220 or you can optimize with this high power connector within your garage at 70 amps, but you can plug directly into a 110. So wherever you go, as long as you can find a plug in the wall, you can plug in and charge your car.
Well, I'm not sure I can get my head around this, but can you foresee the day anytime soon where McDonald's, Wendy's, Taco Bell, Burger King would have a section with, say, 220 plugs, where the electric car people could pull in, get fries and a burger and recharge the car?
I'm having those conversations even now. There's a lot of appetite, pardon the pun. There's a lot of appetite for this, not just among, the food vendors, but we've had very productive conversations with hotel chains, both at the high end for
convenience stores, 7-Eleven.
Convenience stores, 7-Elevens, any place where people would reasonably stop to take a break or to grab a meal or to overnight.
Any breakthroughs coming down the line in terms of batteries, longer life batteries?
There absolutely are. Longer life is not as much of a concern, frankly, as higher energy. The more energy you can store in the smaller package, and the more miles you can put on a vehicle.
If I run the battery practically down, how long does it take to recharge it?
3.5 hours is the quickest that you can charge it.
220 volt or 110?
220. 220. That's 220 at 70 amps. Okay.
220 is what you have on your washer dryer machine.
Correct. Most folks have it in their garage or with their washer dryer, and so that's, now I should be specific. That's 70 amps. Okay. That's using what we call a high power connector that we develop and sell in addition to the cars. That allows you to draw 70 amps off a 220 circuit. Ordinarily, that 220 circuit is delivering 30 to 50. Okay. So if it's in that range, then it takes you 6 to 7 hours to charge the car. And the car can be plugged, it must be said, into that wall socket over there at 110.
But if you plug it into 110, it's more or less a trickle charge, isn't it?
It's a trickle charge. That's if you're coming from a dead battery, that's 24 to 36 hours, so that's going to be a long time.
Well, what about safety mechanisms? What are the safety problems? You have a crash, can the battery explode, set fire to the car?
Well, no, not at all. In fact, it was the first and most important thing that we solved for when we were developing our battery packs. And the fundamental rule that governed the design was that a thermal event in any individual cell cannot propagate to any adjacent cell. So we have both active and passive safety management systems.
Sounds scary.
It sounds scary, but I don't know if it compares well to a gas tank erupting in a traditional vehicle environment. But the point is, it can be very easily contained, and we contain it in this battery pack.
It occurs to me, you're dealing with electricity here. Is there any safety consideration about getting electric shock from the car, touching the car at the bad time, or being inside saying, turn this thing off?
No, just as with hybrid vehicles that have substantial battery systems now, there are very sophisticated shut-off mechanisms that isolate the battery from the car. So if there were a crash event, there isn't current running through the frame or through the metal.
Well, this car doesn't require any, well, I guess a grease job now and again, would it?
No, the fact is that because there's so few moving parts in an electric drivetrain, the motor, the battery, and the power electronics, that's the whole powertrain of the car. If you include the gearbox, you've got about somewhere around 10 moving parts. Very few friction parts leads to very little wear and tear and very little breakdown, so very little serviceability around the drivetrain. Of course, we'll do periodic software upgrades, but we'll be living in the future here where we can beam those software upgrades to you by satellite, so you can have a fully optimized vehicle or a fully diagnosed vehicle remotely. Frankly, I think we're at an interesting period in the automotive industry where actually this hasn't happened since the turn of the last century, where a number of new entrants are coming in and trying new things on for size.
Yeah, that's interesting. Anybody who knows automotive history knows roughly the period, 1900 to 1930, there were all kinds of
right.
compares.
Yeah, that's about right. Industry consolidation started to take place in the 20s and was sort of reached its logical conclusion in the mid-30s. And since then, folks have tried to start new car companies.
With Tucker?
Yeah, like Tucker, like DeLorean. In most cases, they did it around a new product concept or a new brand, as opposed to new core technology, which is what's different about what's going on right now. I mean, companies like Tesla are starting from the inside out, which is design the new drivetrain, be disruptive on that core technology, and then productize around it, okay? Where some of these earlier efforts were more about,
new design of the exterior.
Yeah, Tucker, it's moving headlights, and DeLorean, it's the stainless steel and the gull-wing doors. But those aren't sustainable advantages over the long run.
At any point, and if so, at what point, did you say to yourself, electric cars, I have the concept, I think it can be catalytic, to use your word, but big automobile, Detroit, Japan, Germany, whatever, they don't want this car, and I'm really just sort of tilting at a windmill here.
Well, you know, I think that that's a process. I had no inhibitions about taking on this project and putting it up against those kinds of barriers, because I think, you know, it's certainly the culture of Silicon Valley, and my experience is informed by that.
Well, with your experience in Silicon Valley, you know as I know that one of the things there is either go big or go home. Are you big enough to go the distance?
We're not big enough yet, but what's also important in Silicon Valley is leadership, to be first.
Dear Mitt O'Connell, the key to lowering the price of the car will be the battery. Currently, the battery, just the battery pack for the Roadster, costs more than $30,000. Coming up next, the state of the electric car industry from two writers on the beat. So stay here with us.
We're joined tonight by two gentlemen who follow closely the automobile industry. Jim Motivalli is an environmental writer, speaker, and author. He's a regular contributor to the New York Times automobile section and Wheels blog, among numerous other publications. Matt DeBoard also writes about automobiles and sustainability for national newspapers such as the Washington Post and Los Angeles Times, and he's a regular contributor to Slate's The Big Money, where he writes the Shifting Gears blog. Gentlemen, thank you for being with us. Let's talk about electric cars. What's the first and most important thing people should know about electric automobiles?
I think people should realize that they're coming a lot faster than they think. The common wisdom is that maybe it's 5 or 6 years down the road. I think it's more like 2 years down the road. And I think we're also starting to build the electric car infrastructure very quickly. So I think most people alive today are going to end up driving electric cars exclusively. And I know I'm more optimistic about this than Matt is.
Well, Matt, you disagree with that?
I do think that Jim is correct that we're going to be seeing widespread electrification. I just think it's going to take significantly longer. Although I do think that we are going to start seeing more electric cars coming into the market. We're going to see not just all electric vehicles, such as the Tesla Roadster, but we'll be seeing plug-in hybrid vehicles, and we'll be seeing different kinds of hybrid technologies.
Let's talk about the Chevy Volt. Is this the car that can save GM?
No.
Yes.
Definitely not.
Oh, well, there's disagreement here. Well, give me the argument why you think the answer is no.
For one thing, it's not going to be built in high enough volumes to really save GM. I actually like the Volt. I think it's a good concept. I think the extended range idea is good.
But this gasoline engine in the Volt can create, as long as it has gasoline, say what, 10 gallons or so, it can keep your electric engine going.
The battery has about 40 miles of range. And to extend the range, when the battery runs out, the gas motor will kick in and give you, anywhere from a couple of hundred additional miles to 200 or 300 more miles.
The Volt is going to be like $40,000, which is not, to me, a mainstream high-volume car for GM. It's more important that they have credible small cars in the market than the Volt program, because I don't think it's going to be, at least initially, a very big volume car for them. The Volt, as presently conceived, I don't think will save the company.
Well, Matt, I can at least mentally imagine people who work for GM beginning to throw their shoes at the television set at this time. But you said you think it might.
Well, I think that General Motors as a corporate culture has gone through a sea change because of this bankruptcy proceeding. And there's a lot of enthusiasm and belief behind the Volt project. General Motors, if they were smart, might take a real flyer with the Volt and price it at a place where they're basically going to lose money on it for a while, because they're going to lose money on it anyway. If they can get the pricing on the Volt down into the same neighborhood as what people might pay for a Toyota Prius or a Honda Insight, then they might be able to convince consumers to come over with that technology.
Right now it's priced at about $40,000. If you get it down to what, 25?
If they could get it down in that $25,000 range, they would probably lose money on it. But
we should point out there's a $7,500 federal battery rebate on the Volt. So you do get that.
You get that discount. That's correct. Yeah. But in a lot of cases they have to factor that into the final price that the consumer is going to be confronting.
In your opinion, based on your knowledge and your expertise, when does the public get an electric vehicle with a range of 250, 300 miles at least, with a price tag of $22,000?
I would say that by 2020, maybe 30% of the cars on the road will be battery, electric, or plug-in hybrid. And hopefully we will have cars that meet those specifications by then. I would think by then.
Think too optimistic, man?
I think that's too optimistic. I think we might have vehicles that are capable of those performance parameters by then, but they're just not going to be affordable. You know, you can look at a vehicle like the Tata Nano, which is a micro car that was recently introduced in India. It's going to sell for less than $3,000. And this is a vehicle that doesn't burn a lot of gas, gets pretty high mileage, is light. It will have to be a safe vehicle for use in
an Indian car.
An Indian car, but they're planning to export it or potentially even manufacture it in countries that they would sell it in. And a car like this is a fairly low emissions vehicle as well. That's the kind of affordability solution I think we need to move forward. We need more vehicles.
But it's still got a tailpipe, Matt.
It still has a tailpipe.
The tailpipe is the problem.
Yeah.
We need an X over the tailpipe.
Yeah, I think that what we need to do is we got to move toward the X over the tailpipe, but we have to make some immediate progress, because if you accept some of the estimations about peak oil, we're already well behind the curve. So we have to catch up to where we should be, and we have to make some progress immediately, which means we need to see much more extensive hybridization of automobile fleets in the United States and worldwide.
True or untrue? We're at or near the oil peak.
True.
True.
Yeah. It just depends on how you interpret the data. Some people would say that we peaked a while ago. Some people say that we're peaking now. Some people say that we're going to peak soon. And then there are the consequences of peaking, which might mean that we fall off a cliff and the reserves of oil become less and less productive through the rest of the century, or that we're going to plateau and see a period of stable, if reduced, production over what we've seen in the past. We also might be looking at a situation where we found all the oil that's easy to get, and the oil that we're going to get in the future is going to be much harder to find.
I think that's already happened.
Yeah.
And the exact date of oil peak will be clear only in retrospect. We could well have passed oil peak already. I think that's possible.
Well, we're talking basically about electric cars, and obviously whether we have or have not, and how soon, if we haven't reach the oil peak, is really important to the development of electric cars.
I think even without oil peak as a phenomenon, climate change is so much of a driver that I think it would lead us away from internal combustion.
And that's why you think the future for electric cars is bright.
Very bright.
Do you see the United States' dependence on foreign oil, we're weaning away from it now, or not yet?
I don't think we've really started yet. There's so few electric cars on the road that we're as dependent, more dependent we've ever been right now. But I see a clear path to getting away from that dependence. It's going to take a big, concentrated push.
We're certainly behind the curve. If you assume that peak oil either has happened, is happening, or will happen, we're behind the curve of where we need to be.
So we import 6 million barrels of oil a day right now.
Yeah. We consume 40% of the oil that's produced for transportation in the world. So,
how important is Silicon Valley in this equation of electric cars?
I think it's very important because a lot of the people heading these companies are former computer guys. You know, it's uncanny to me how many have made that transition. You look at Tesla, the head of it is one of the founders of PayPal. Wego is headed by the former head of MindSpring. So there's a lot of internet players now getting into this. They see it as the next new thing is electric cars.
There's a very strong belief that the way that they've done business in Silicon Valley and the mindset of Silicon Valley is something that can solve a lot of our mobility problems in the future. You know, I'm somewhat skeptical about that. You know, I think that there's a belief in Silicon Valley that if you bring enough good ideas and enough sort of pure smarts to the table, you can fix anything. Unfortunately, global manufacturing of something as complicated as an automobile somewhat resists that, I think, in the end.
Well, also, I think one big difference between computers and cars is the basic battery chemistry. It's not like Moore's Law where it gets 50% cheaper every year or whatever Moore's Law is.
Yeah.
It doesn't.
They
it's
often,
hard to improve.
They often talk about Moore's Law and try to apply it to
I don't know what Moore's Law is.
Moore's Law is basically the idea that computing power, processing power over time just gets better and better and better. Okay.
And cheaper.
And cheaper, yeah. And they keep talking about Moore's Law as though it applies to batteries in the same way. But this is a good example of why cars aren't computers, because there are enormous problems associated with getting batteries that would be used in personal transportation type vehicles to the point where they can provide adequate power, adequate range. There's just some restraints within the chemistry that haven't really been cracked yet.
The lithium-ion batteries. Is that the future of the batteries we now see it?
That is the leading technology right now. Every car maker is looking at putting lithium-ion batteries in battery cars. It's not to say there won't be a better technology in the future. I mean, it's one of those things we're trading one dependency on another. Problem is you got to start from scratch to develop a whole new battery technology, and lithium-ion at this point is fairly mature technology, so it's going to be the technology for the introduction of these cars.
Lithium-ion is the only thing that gets anywhere close to giving you what you get from gasoline, and it doesn't get there yet.
What direction do you see this part of the business heading? That is, we've talked about the battery part of the business, the design of a battery car.
Batteries are going to be a huge part of the equation. That's certainly the thing that's going to fail first. And the life cycle of a lithium-ion battery is a big question mark, really. Is it going to last 3 years, 5 years? And it's going to be the most expensive thing to replace, too. So the action's really in batteries. The basics of the electric car are the same as they were in 1920. It hasn't changed that much.
Why has it worked out that most of the battery manufacturing and battery breakthroughs, new technologies being developed and manufactured in these other countries? Have we missed the boat here? Do we need the president to get some new impetus to so we can take part, if not dominate, that market?
This is a point that Jim and I think might have a point of disagreement on. I think that that we're maybe overly concerned with the idea that we're going to become, as they say, dependent on Chinese battery makers in the same way that people often talk about how we're going to be dependent, or we are currently dependent on foreign oil sources. If you look at a battery, it's not a commodity, but it wouldn't necessarily be a bad thing for the battery making to be located in low-cost environments, such as an Asian manufacturing environment, because the cost of these batteries is going to be driven down over time. Whereas the design of things like powertrains and the software to run the vehicles that integrates the whole project of having the battery communicate with the car can be better served here in the United States. So, we don't necessarily need to be a dominant player in the battery business, although some people think we do. I for one.
What about the whole green jobs aspect of this? I just love the idea of these old closed car factories now producing green tech, green batteries.
Yeah. I think it could wind up being one of these things, though, where it's just from the economic standpoint, it winds up being much more cost effective to outsource the battery manufacture and to keep the engineering design expertise at home.
The Department of Energy has this Advanced Technology Vehicles Manufacturing Loan Program, otherwise known as ATVM. What exactly is this program set up to do?
These companies are trying to get manufacturing in the U.S., and without these loan programs, all the manufacturing is going to be overseas, particularly in China, all over Asia, not in the U.S. As it happens, battery manufacturing is very automated, so it's not even that much more expensive to do it in the U.S., but it's perceived that way, really. And right now, we're evolving towards an all-Asian battery manufacturing industry, and I don't think that's good for the U.S. So I think that program is excellent. Every car maker is vying for some of that money.
Now, do we know, I'm sure it's a matter of record, do you know how much each one of these received?
Tesla received a loan, $465 million. Ford got $5.9 billion, and Nissan got $1.6 billion.
And it's worth pointing out that GM and Chrysler did not qualify for this because they were considered not viable. Yeah. Both of them were going through bankruptcy proceedings, but they will probably get funded. This was only the first of probably 3 rounds of funding. They'll probably get funded later in the program.
Tesla had to go through an entire viability exercise, in fact, of unveiling the Model S and showing that it was for real. It had been talked about as a kind of a conceptual exercise, but they actually had to put the thing out there and show that they were committed to building it. in order to demonstrate viability so that they could qualify for their component of the money which they've been waiting on for a while.
Would you include them in the ones who had a chance, or you think they'll fall by the wayside?
They've delivered about 500 or 600 of them so far, which is not a lot. I mean, when you think about it in Detroit terms, it's hardly even worth mentioning, but yet they're the leading electric car player today. They've got the most cars out there. So it's still a very small industry. It's going to have to ramp up very quickly.
They may survive and continue to be one of the main players in this segment of the industry, but they might also run out of money eventually. And what could conceivably happen is that they might start to become more of a powertrain manufacturer, supplier of electric drivetrains to other companies.
Are they likely to be automobile companies whose names we now recognize, or we new GMs, if you will, or new Fords coming on?
I think the big three are going to become the medium-sized three, and we're going to have a whole lot of smaller players that people don't really know the names yet. We're talking about Bright Automotive and Aptera and Think Global, and there's a lot of companies out there. WeGo, the WeGo Whip. People are going to end up driving WeGo Whips. You put together a bunch of suppliers, same way you might put together computers and your name be Dell, and you have a car. You basically have to design a body and then put these components in it. So entrepreneurs are really seeing a way to create a car company in a way that was been very difficult for the last 50 years.
In a lot of ways, it resembles the early days of the car business as we currently know it, when there were a lot more players in the game. Some of them will fail, some of them will sort of succeed moderately and may stick around for a while, and some of them will be picked up by larger concerns and have, for want of a better term, have their technology kind of cherry-picked.
I'm not going to concentrate on this, but when we were talking about Silicon Valley, as applied to automobiles, we know about computers. When we think of Silicon Valley as a potential new Detroit, Detroit fades off, Silicon Valley comes in.
Well, there are some people who've been talking about a kind of connection between Silicon Valley and Detroit. Silicon Valley has the brain power and the entrepreneurial energy that's going to save Detroit and enable Detroit car makers to once again become important in the global car making scene and to survive in America and to become relevant to American consumers. Of course, meanwhile, you have Detroit kind of relocating to the south, to states like Alabama, Tennessee. So there's also this kind of shift in the manufacturing capacity to other parts of the country. So, we might be seeing a Silicon Valley, Detroit South kind of connection instead of a Silicon Valley, Detroit Midwest connection.
Yeah, you could have the headquarters in Silicon Valley, but the car making largely in the South.
Exactly,
That's the cheapest place to do it.
Exactly.
Or overseas.
Let's get back to the idea. Has or has not the government done enough to encourage, get the public to accept hybrids and or electric cars?
I think they're doing a lot now. They haven't done enough in the past, and they're going to absolutely need to do more in the future. It's not going to work. I mean, we're not going to get ourselves to where we need to be in 40 to 100 years without a lot more action on the part of the government.
See, you think that it's going to happen over 30 or 40 years. I think it's going to happen a lot faster. It has to happen faster.
Yeah. Well,
or we're looking at a broiled planet from global warming.
I take a more practical. The reason I take a more practical approach is because I think that the constraints of what we're up against are pretty vast. I mean, we're talking about replacing a vehicle fleet of 210 million vehicles with something that's going to be less damaging to the environment potentially over time and is going to help us conserve our oil supply and solve a lot of problems. And I think that needs to be executed gradually over the period of the next 40 years. I think if we tried to put the pedal to the metal, it would be extremely cost prohibitive and just not manageable in the short term.
And your argument is have to do it. It isn't
we
an
have
option.
to do this, yes. And you had brought up the point of the public. Are we doing enough to educate the public? And I would say no. I think there's very low public awareness of it right now.
But good point. It had occurred to me before, but I'd forgotten it. Because there are fewer working parts, you don't need much inspection of the car, and the whole auto parts business will change. Certainly you need things like tires, but there's a whole list, a whole array of other parts, automobile parts suppliers and parts stores are going to have to change dramatically.
Right.
If we
That's
reach
a
this
big
electric
part
car
of this, yeah.
Well, not only that, but car dealerships will have to deal with the fact that people may not be bringing their vehicles in as much for service. I mean, it depends on reliability issues and how all these technologies work out. But there's a famous scene in Who Killed the Electric Car, the documentary about the EV1, where they describe the maintenance requirements of a typical internal combustion automobile versus the electric vehicle, and you've got this guy showing somebody with like 4 parts for the electric car, and then all this other stuff. There's all this dirty stuff, that's associated with servicing the kind of car you might drive today. It's an internal combustion engine car. So I mean, dealers like to have people come in and service their vehicles, so they may have to deal with this from an economic point of view in the future.
Help me envision the future. How soon do we see plug-ins for electric cars at places like 7-Eleven stores, McDonald's, Burger King,
Well, it's great you
KFC?
should mention that, because I think one of the keys of this is charging stations, particularly fast charging in big box retailers. And the first McDonald's opened with a charging station last week. The first hotel with a charging station happened last week. I think this will become a major competitive advantage. And you can charge a car in 15 minutes with fast charging, which is about the time it would take you to go to Starbucks and get a latte and drink it.
Excuse me, you don't get a full charge in 15 minutes.
You can get a full charge in 15 minutes.
Didn't know that.
You can, with very high voltage charging, which you're not likely to have at home, but you will have in these parking lots.
So parking garages,
Parking garages
Walmart,
too.
Target,
Walmart, Target,
McDonald's, Burger King, KFC, Taco Bell, you foresee them having these plugins?
Right, so if your choice is between McDonald's and Burger King and one has fast charging, which could even be free, you're going to go there. So it's a competitive advantage, then soon they'll all do it.
Is this too wild a dream, man?
No, I think if we're going to have a successful build-out of electric cars in any scenario, then we have to have fast charging, and it has to be widely available. And Jim's correct, it will be a competitive advantage to somebody who puts a fast charging station in their parking lot, because a lot of people are going to try to, if they purchase an electric vehicle, they're going to charge it up at home, but it's going to take a long time. They're going to have to do it overnight. Fast charging is critical for this.
What is or will be the vision of the auto industry in 2050?
I think in 2050 we will see almost total electrification of the auto industry. Everything will be involved in plug-in. I think
By
we'll
that
be,
time.
By that time, and I think we'll be well on our way to evolving the hydrogen-based energy economy.
Matt?
Widespread electrification, I think, is pretty far out. Widespread hydrogenification is even farther out. I'm a little bit more committed to oil as our primary source of transportation fuel over the at least the short term. But what does that mean for our global relations with oil producers? Are we going to remain, as they say, dependent on foreign oil, and is that a good thing or a bad thing? I think it's a good thing. I think it's a good thing for us to remain enmeshed with the oil economy.
Do you think it's a good thing?
I do. I think it's critical that we maintain positive economic relations with the countries around the world that are the large-scale suppliers of oil, if we're going to be committed to oil in any way for the future.
And you think we have to be?
I think we have to be.
We have to evolve towards zero emission. I don't see any way of avoiding that. The climate imperative is too big. So I think we get to the point where we have to say that tomorrow's car doesn't have to be 100% better than today's car for us to switch to it. There are other things that are more important than whether I have the best or the sexiest car, and that's the future of our planet, I think, overrides that.
Both of you have been terrific explainers and very good teachers, and I appreciate it. Just curious, have you changed much about how you write about the automobile industry, or is it still pretty much as you started?
I've changed a lot, actually, how I write about it. The automobile industry has become extraordinarily interesting over the course of the last year and a half because it's been essentially in a state of worldwide crisis. And a number of issues that were sort of hanging around on the periphery of writing about the car business have now come to the forefront. So when you write about the auto industry now, you're writing about climate change, you're writing about energy politics, policies, you're writing about chemistry and technology, you're writing about Silicon Valley and the entrepreneurial mindset. It's just not writing about this or that new vehicle that's come out, or this or that corporate movement within one of the big car companies.
I totally agree with Matt. It's a great time to be covering the auto industry because it's so exciting. It's changing so rapidly, and trying to see ahead, trying to have a vision of what might be, I think is really challenging and really fun and really interesting. If you look at 100 years of internal combustion, you know, between 1955 and 1965, the wheel cover design changed. You know, the engine was basically the same one, you know.
So we went from fins to no fins.
Right, so, but what we're looking at now is a complete revolution. It's a total new car industry.
I thank you very much. I learned a lot. Appreciate your time.
Thank you so much.
Thank you so much. If you would like to add your name to an email list for information on upcoming programs, or if you would just like to send a question or comment, please email us at viewer@hd.net. Tonight, electric cars. Are they the next revolution in transportation?
These are very expensive vehicles to build. There's no clear evidence that consumers will adopt them on a large scale.
And Tesla, the electric car company that was first out of the gate. We'll talk to one of the developers.
We are certainly first. We have a very strong lead. Companies like Tesla are starting from the inside out.
Plus, how soon before we're all plugging in and powering up?
I would say that by 2020, maybe 30% of the cars on the road will be battery, electric, or plug-in hybrid.
We'll bring you the news tonight on Dan Rather Reports. Good evening. Dan Rather reporting tonight from New York. Our program this evening is about a very quiet revolution in the automobile industry. Electric cars that are whisper quiet and headed for a dealer near you. You may not have seen one in your own town yet, but just wait. Big auto companies and small startups are racing to get electric cars on the street. The technology is here, now, and many auto experts believe so too will be the demand. The next Detroit may well be in the Silicon Valley, where many of America's next generation of cars are being developed. The hybrids were just the beginning. Now some companies are tossing out the gasoline engine completely for good. For our program tonight, we have conversations with several battery systems.
These are the Wild West days of battery technology. There are all kinds of chemistries out there that conform to different kinds of performance parameters. There's lithium phosphate, lithium iron, lithium cobalt. There's sodium batteries. So the battery technology is all over the map right now. The winners will be several. There'll be the cost winner, there'll be the packaging and performance winners, there'll be the company that can sort of come up with the best compromise.
First out of the gate was an all-electric roadster developed in Silicon Valley called the Tesla.
You have to give credit to Tesla. Tesla was firstest with the mostest. You know, they took this sports car based on the Lotus Elise. They developed their own proprietary battery pack, a very big battery pack, but reasonably cheap, and so they built this sports car. You know, it's $100,000 and some odd, so it's not a mass market vehicle. In any event, they really were the first company to put a lithium-ion battery pack on board and make it work.
We'll have much more on the Tesla later in the program. And the big car companies are now coming on fast. Nissan of Japan recently announced production on an all-electric car with an environmentally friendly name, the Leaf.
Nissan has decided to make a strategic move in the direction of pure EVs. The company CEO Carlos Ghosn has said there's a million car market out there that's not being served. Nissan can build these cars. They've got a good technology and good batteries to do it. The Leaf is a real car, 100-mile range, 90 miles per hour.
People with intimate knowledge of the next generation automobiles. We began where else? In California, the trend-setting capital of the world, home to Silicon Valley, the brains behind many of the new cars, and where for decades, automobiles have been about so much more than just getting from point A to point B. It's also the state with the most cars, and Los Angeles still has some of the worst air pollution. So into that environment comes the Phoenix, the Tesla Roadster, the Coda, the Leaf from Japan, the BYD from China, the Mini E from BMW, the futuristic Aptera. Do a quick Google search and you'll see how many electric cars are on the way. Electric cars that will forever snub gas stations. All they need is a wall socket and, like their owners, a little time to recharge. We began by speaking with someone who knows a lot about cars and California drivers. Dan Neal is the Pulitzer Prize-winning automobile writer for the Los Angeles Times.
Really, the transformation in the American rolling stock will be breathtaking, I predict. We're going to see millions of electric vehicles on the road very, very soon. They're coming fast. When they get here, they'll be expensive, and the real challenge will not be the technology on the four wheels, but the way we connect them to the larger electrical infrastructure. People say, well, we can charge them at home. The experience in California early on has been it's been difficult to build and connect chargers to people's homes. There's an issue of standardization. Different municipalities have different codes that have to be inspected. You know, it's a very bourgeois thing. You know, you've got to have a home in the suburbs to have an electric car. Where do apartment dwellers plug in their cars?
But perhaps more importantly, where do they get the money to buy them?
The problem is that these are very expensive vehicles to build, and there's no clear evidence that consumers will adopt them on a large scale. But nonetheless, manufacturers are building them. What you're seeing now in the electric vehicle market is just the first few thousand of these cars that are being built to satisfy the zero-emission vehicle mandate. So the government has been very active on this front. The Obama administration has passed a very demanding fuel economy standard, 35 miles per gallon by 2016 and on up from there. Those standards really cannot be met by current technology. And so the pump has been primed for electric and plug-in hybrid vehicles. That's one thing. The other thing is that the Obama administration has put billions into advanced battery research and has given billions to manufacturers to defray the cost of the initial investment in battery factories, in electric cars. Electric vehicles work great in Southern California because batteries are like people. They like it warm and not too warm, not too cold. Battery-powered cars are going to have a much lower performance envelope in Michigan or in Maine or in New York City because batteries simply don't work as well in the cold. This is a blind spot when it comes to the electric vehicle enthusiasts in California to say, well, why doesn't everybody have a Prius or a Ford Escape hybrid or indeed a full electric vehicle? Well, because a full electric vehicle probably won't work as well in Ontario. Not probably, definitely.
Batteries are the keys to winning this race. New technologies are being developed to squeeze every mile out of ever more complex.
Our top speed, 5-seat, and Nissan promises that it will not be that much more expensive than an ordinary car. Nobody really knows how this is all going to work out. We don't know if Nissan's choice is a good one or not. It seems like a good idea sitting here in Southern California. But the world and the market will have to have the final say.
Meanwhile, Toyota, the world's largest car maker, has decided to wait. recently saying all-electric technology is just not there yet. And they also have a huge seller in the hybrid Prius that runs on gas and electricity.
With regard to Toyota's decision to stay with hybrid and even plug-in hybrid technology as opposed to pure EVs, you have to respect Toyota's decision there. These are people who really know what they're talking about, and they were in the market with the first real game-changing hybrid. And so their decision not to pursue pure EVs at this time, I think, has to be taken seriously. There are a couple of caveats. Toyota has the patents on a particular kind of hybrid technology. They call it hybrid synergy drive. Naturally, they'd want to pursue and develop that. They're a very methodical company. They're more likely to want to develop that technology incrementally year after year than throw the long ball like Nissan has done and to develop a battery electric vehicle.
And into the race comes General Motors with another kind of hybrid technology. The GM car will be called the Volt and will go on sale in 2011. It's designed to compete with Toyota's hybrid Prius.
There are actually two kinds of hybrids, a parallel hybrid and a series hybrid. The Prius is a parallel hybrid, and it works like